Hey, it's Coach T. We're back with another object-oriented quick code video in Python. So in this video, in order to really follow along with me, you need to understand what classes are, and I don't mean classes that you take, but classes that you create. You need to understand the basics of what objects are, how to pass arguments into parameters, and you need to understand how to call functions and act on functions. So if that's confusing, I'd recommend you go back to my earlier videos on variables, on the basic syntax, on functions, and then also the stuff starting with the last 2 or 3 videos on objects. I do try to keep the videos short. I know the last few have run long, but that's because we are moving out of tutorial land and we're kind of moving into the more intermediate levels of using Python. So if you can master what we're talking about in these videos, object-oriented programming, you will be well set up to start doing things like Flask or Django, tkinter, PyQt, Pygame, and really to start building your own software, which is ultimately the goal, right? To build cool things that you can use to solve problems in your life or somebody else's life. But we are definitely getting to the point where the difficulty curve goes up, at least for a while, until you start to understand how to actually do object-oriented design. In this video, we are going to really focus on how do I make a class interact with another class. My goal here is to go slow and to show you the different steps. I will say, though, that with my experience in C#, which at this point dwarfs my experience in Python, I was able to go right back to Python's class declaration systems and start making classes interact. I did no review. I was able to just go back and use the logical experience that I had from C# and a little bit of monkeying around with the Python to get the syntax correct using the recommendations in the IDE, and it clicked. So this is one of those examples where oftentimes you read online and people say it is very easy to learn your next programming language once you have one down. This is one of those times where it's really, really true. Python, JavaScript, Ruby, Java, C#, C++, they all share an object-oriented design. So if you learn it in one, you can learn it in the others very easily. So we're laying the foundation for you to be successful in whatever language you ultimately decide to really focus on. So with that said, my only other request is if you like the video, if you like this kind of head-first step-by-step approach, subscribe to my channel, share it with somebody, and hey, leave some encouragement for another learner in the comments. Let's try to make it a positive environment, because what we're doing is no longer really easy, but it is doable, and it is something that we can all learn to do. So let's switch back to our classes. I still have the big idea up here for what classes are, because I want you to revisit this definition and really be thinking about the objects that we are creating, which include things like fields, very important for what we're talking about in this video, and methods, which are class-specific functions. We can instance those classes because the class itself acts like a blueprint to create or instance new objects. Very important to understand that distinction. Also, I want the syntax reminder up here that you need to use the class keyword, and you also need to include your dunder in it, which we're going to extend this with a reference to self. So you have to have the reference to self. This is where I see people struggling when I'm talking to them in my learning community, with my brother, with the people that I know who are learning Python. It's some of this self syntax, self.syntax, that throws people off. So with that said and that out of the way, let's take a look at what we're doing. I have built to demonstrate how classes interact a very simple battle system. In this case, you always deal 3 damage, you always gain 10 XP whenever you call the method attack on the character class. But the structure that I've chosen to demonstrate this with does a couple things. First of all, it shows us how to instance a class within a class, so you have an object within an object, which we're going to do a whole video on that. But also, it shows us how to get one class to interact with the methods of another class. Very, very, very important in order for you to be successful with object-oriented programming. We need to get comfortable with parameters and arguments, with instances and objects. So here's what I've got. A really dead simple, stupid definition of an object called sword. So I have sword, I have my dunder in it, I'm not passing anything into it. I always can just declare it with something as simple as tool equals sword. That will give me access to these values. So now I could print tool.dmg. I could sell it if I wanted to for the value. See, I'm not throwing any errors with the syntax, and it would print off 3. I don't want to print it right now. I don't want to waste the time. But this simple sword declaration is how we declare a class. And then we can instance it however many times we want. We can have sword1 equals sword, sword2, sword to infinity and beyond. It doesn't matter. We can do it as often as we want because the class is the blueprint, and then these variables are the objects or the instances. I don't need to declare a sword in order for what I'm going to do because I actually have the character class declaring or initializing it's a sword on its own right here. So the first step to understanding what we're talking about is the class structure for sword, which I think is pretty clear. We're going to collapse that. We're going to take a look at the character class that I have set up. I know not everybody who's learning Python wants to develop video games. Python is not a great language for developing video games, but you can. But I do think that learning with an RPG or a slightly gamified system does make some of this stuff more concrete for us and a little bit easier to learn from. So let me zoom up so that my face is not in your way. And now let's take a look at class character. So class character that initializes, drag the wrong screen, that initializes the class. So anything that we create would have to reference a character. Dunder init takes 2 arguments other than self. It takes name and it takes character class. We are going to run into an issue here we're going to talk about that will lead us to polymorphism eventually. But we have self.name is the name variable passed from here. And then we have self.class, arguably not the best terminology, but we're passing in character class. So fighter, paladin, rogue, monk, druid, whatever. Right? And I don't have an enumerable list here. It's not something we've talked about, but really, I mean, you can pass anything in. And I'm going to cheat using character class in a little bit to declare a beast. And then we have self.xp, we have self.weapon, and here's where self.weapon becomes sword. So in this case, whatever is stored within a character instance's weapon is always going to be a sword. Not necessarily the best way to do this, but for demonstration purposes, you'll see that I can use this approach to get damage out of the sword class. So that's it. Very simple. You could go beyond. You could use a list to create an inventory. You could use a dictionary to create like an inventory and weapons. You could use Booleans to determine like is alive, is bleeding, is over encumbered. You could do a lot of different things with your initialization here. And then we have 2 more fields. So we have, or 2 more methods rather. We have describe character, which will pull the name variable into a sentence that says name is a level of class with self XP points. Now I have an unsafe structure up here. I am not enforcing typing at all. So you could get real goof troop here. You could have 5 is a level blue true with bananas XP points. There is a way to specify typing up there in the declaration signature, but it's not something that I've covered here, and it's not something that I want to cover right now, but I will eventually cover enforcing typing in that signature. Other languages, like in C#, it's just mandatory. So in Python, that flexibility is kind of the key, the clue. So we haven't talked about it yet. And then we have attack. Now here is something new. Let's, that did not blow it up. I want to really draw attention to this. In my signature for attack, I'm defining a function. I'm passing the self, all the self variables and fields go into it, but I'm also passing a target. The target is declared when I attack with my character. I need to specify who the target is going to be. In the simple version of our battle system from way back when in the mini project, we didn't really have a means of doing this. But when we come back and we do battle system 2, we are going to be able to specify who we are attacking. And because we'll have multiple instances of creatures to attack, you will be able to kill them off slowly, right? By dealing some damage to them. But it's very important that we stop and pause here and think about what does it mean to have the target there. This gives the character class's attack method access to the information in a different class object. Whatever object we pass in here, which will be enemy, the enemy or the attack method can then read information from the enemy. Very important. This is a more complicated structure. So let's take a look at this right here. There it is. So from attack, as soon as you call it, it prints off self.name, my name, attacks, target.name. So in order for this to work, the target also needs to have a name class. And here is where I'm not talking about inheritance and polymorphism, but those concepts build on object-oriented design to ensure that we have all the classes and data types that we need. But we also need to be aware that if we're going to do something like this, the target has to have a name variable or else we'll throw an error. I'll show you what can happen in a second if we don't. And then also the next line that it prints, self.name deals however much damage is assigned to this weapon that I instanced. Now, if I back out, zoom out a little bit, because it's a little overwhelming. If I look at my sword class again, if I did not have this line, this would also fail because it wouldn't have a variable to access there. So again, we're starting to think about how do the classes and the fields interact with one another. I need to be sure as I'm architecting my classes that if I'm going to have a method that calls on a variable from another class, I got to make sure it's there or else I'm going to shoot myself in the foot. So be aware of that. And then finally, we're going to add 10 to our XP stat. So not very complicated mechanically, but conceptually, this could be a lot of new stuff for you. And it's something that I'm going to encourage you to play with. Make sure that you're using your self syntax. Make sure that you're using your dunder and knit to properly initialize your classes. And make sure that you're using your define keyword when you're creating your own methods. Those are a couple areas that I know I struggled with, I broke down on. Okay, let's see it in action. So every character class requires a name and a class when we instance them, when we initialize them. So we have player variable, which is going to be of the character class type. His name is going to be John Halo, and he's going to be of class type Spartan. So that means that when I instance him, his name is set to John Halo, his character class is set to Spartan. Then I'm also going to instance, before I move on to that, then it'll initialize his XP as 0, and it will instance weapon for him as a sword class instance. I need to have the parentheses here, or else I would be working on the class itself. That's not what we want. Almost like a method call, we do want to have the parentheses there to tell Python, hey, initialize, but we're not passing anything in. You're just going to create your reference to yourself. Everything else is initialized during that init process. Okay, then I'm going to declare an enemy instance of character class. Its self.name will become giant spider, and its character class becomes beast. Also, inadvertently and intentionally, it's going to have a sword weapon. Now, here is where simply working with classes can get in our faces. What we want to start to think about is polymorphism or inheritance, where we might have a character class that only has a name and maybe some core stats, and then we have a player class that would have things like a class, their XP, their level, their inventory, and we can also take a monster class and inherit from character class so that it has a name and the core stats, but then maybe it has its own methods and attacks. Maybe it has a type, something like that. The structure that I have here is very rudimentary, but it does allow us to describe the character. We can even do enemy.describe character. And then here is another key thing. We are going to have the player instance attack. So we're calling the attack method that they both have because they're both character class instances. But the attack is going to target the enemy. So I'm passing the entire enemy class in. All of its fields, all of its variables are then accessible to the player when it attacks to read. Writing backwards can be a little bit more complicated, but for simple demonstration purposes, what this structure, player.attack with enemy as the argument, allows me to do is to see the enemy's name, see its XP, see its weapon, see its class. And then because our method is very simple for attack, all it does is say we're attacking the target, right? Target is the enemy being passed in. Then it will deal damage, blah, 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 and it gives itself 10 XP. Very simple. The enemy target class itself is in no way affected by this method. We're not getting into that right now, and I'm running long, so we're not going to deal with that right now. And then finally, we're going to do a print. Just for simplicity here, we're just going to print off a line, and I want to do this twice so that the attack is really clearly separated from the descriptions. But what we should see is if this works by passing this reference over, we should see that player.describe character should go from 0 to 10 XP, the player instance under John Halo. Did I throw an error? Oh, crap, I did. Self.name is a level, self.level. Character object has no attribute level. Okay, hold on. Debugging. Oh, you know what? I got rid of self.level because I was thinking it wasn't going to come up, but it does. Okay. Debugging process. Part of the learning process. Kind of critical. And also inventory. Oh, right. Okay, so my original video structure had an inventory, but then I was going to assign it as a challenge, and then I forgot to remove the references. What a mess. That's okay. Should work now. Okay. The reason I removed self.inventory is because it actually prints off kind of goofy. It prints off this. That's not actually how we want to demonstrate and print off an inventory. So that's part of why I removed it. So anyway, John Halo is a level 1 Spartan with 0 XP points. He is carrying Bupkis, nothing at all. Giant Spider is a level 1 beast, right? That's what I passed in when I declared them, that John Halo is a Spartan, Giant Spider is a beast. Then John Halo attacks, and here it is accessing that Giant Spider. It takes, he deals 3 damage from the sword instance, and then we're redescribing them. He has a level 1 Spartan, and now he has 10 XP points, still not carrying anything. So I want to change one thing before we wrap this video up. We are going to set an XP value of 10. So I don't want to call it XP here because it would be confusing and it would initialize with too much XP. But in this case, the value of what you get when you kill it is going to be 10, okay? And what I want to do now is I want to change the amount of XP that it gets to be target.kill value. So now, if this works the way that I believe it will work, now John Halo should gain the 10 XP, and let's set it to a big number. Let's set it to 50 instead. So both classes, unfortunately, both instances would have a kill value of 50. That is where polymorphism comes in play, but we will get to that when we get to that. Not yet. So here it is. So now I'm no longer just saying he gets an extra 10. I'm saying he gets the value that is specified in the target instance's kill value field. So we've passed information, we've copied information over from one class instance to another, from the enemy instance over to the target or to the player instance. We have also used the sword instance as part of the class player and, class character, and we've used that other class's information in a method call for attack. So it got more complicated all of a sudden, didn't it? This is something you really need to slow down and practice with, because there is no substitute for practice, for building your own simple systems here, for figuring out how to pass the information around and beginning to build the mental muscle to use objects, to make them interact, to screwing it up and then debugging it. There's just no substitute. No amount of reading or video watching is going to help. So I went on for way too long, but Pareto principle, if you watch this whole video, it's 21 minutes right now as of counting, go work for 2 hours on just declaring classes, creating methods, initializing your classes, and making them interact. Go build a battle system. Go build a pizza class, and then have another one that's like a class order, and be able to build on the pizza, and go do something concrete with this, because it is a little bit abstract. So that's it. I'm Coach T. This is a lot on objects, on classes, and I'm hoping that it's not too complicated, but that you're tracking along with me and also applying it on your own so that you too can go build some cool stuff. I did all of this with no review of Python. I haven't written a Python class in like 4 months, probably. But because I understood the object-oriented principles from C#, I'm able to turn around, and as soon as I see the syntax for how it's done in Python, boom, I can do it. So there is hope that you can learn not just Python, but multiple different programming languages, because we're looking at the concepts now, and we're really starting to be able to build neat interactive systems. So with that said, I'm Coach T. Consider subscribing to the channel, sharing this video with your learning community if you think you benefited from it, and I will see you next week, where I think we're going to talk about more about that initializer and instancing more classes, more class objects within a class as you're creating it. Because the computation capability there is kind of the sky's the limit on what you can do once you start thinking about encapsulating your objects. So that's it. I will see you next week with increasingly more demanding video. I got to figure out how to keep these things below 20 minutes.